All right, let's get started. I'm sure people will walk in and they will be sad that they missed the initial part, but it's fine. It's fine. So recent advances in generative AI have, like Stable Diffusion and ChatGPT, have the industry more hyped up than a kangaroo on a trampoline or a caffeine-addicted toddler. This may leave you asking questions like, is the hype warranted? Is the singularity near? Or how do I leverage it? That's what we're going to find out today. So this talk is going to cover these three main areas: some definitions of terms, like what do all these acronyms mean? We'll go touch upon prompt engineering, and then I'm going to apply all of that to a real-world-ish application. The application will be available on GitHub, so you can pull it down, try it out. But first, a little bit about my favorite subject, me. So my name is Phil Haack, and I know what you're thinking. What a great name for a software developer, Phil. Here's my contact info, and I got my first computer when I was around 5 or 6. As you can see, I looked old for my age back then. I've been in love with computers ever since, and I'm probably most well known for NuGet, ASP.NET MVC, and GitHub. I am not an expert in AI or NLP, but I've been building applications that leverage it for a while now, for the past couple years. And I'm just here to share what I've learned. And to get started, we'll start with some definitions, right? So what is AI? I mean, it feels like magic, right? But AI, the definition I'm using is a machine capable of performing tasks that typically require human intelligence. For example, it's not just your unhinged relative who can spout conspiracy theories. Now your computer can. AI can be broken down into multiple kinds. The two main ones we hear about a lot is AGI, or Artificial General Intelligence. This is the AI designed to learn and think and perform at human levels, the kind of AI that can reason for itself and take on any sort of task except opening the pod bay doors, and the kind of AI often depicted in movies. But this is the kind of AI that doesn't exist yet, as far as anyone knows. The kind of AI that's been in the probably multiple talks at this conference is we don't want to confuse AGI with generative AI. This is the kind of AI that we're hearing all about, right? And this is the kind that's exploded on the industry in recent times. So some example, this is AI capable of generating text, images, or other media using generative models. So examples of that are GPT, Claude, Bard, Midjourney, and DALL-E. And generative models are fed these ginormous data sets, and they're programmed to learn to deduce patterns in that data set and then generate new data that mimics those existing patterns. So basically, these generative AIs are monkey see, monkey do. And this data-driven mimicry is a key aspect of this current generation of AI technologies. But for this talk, I'm going to focus on LLMs, or large language models. So this is a deep learning algorithm that can perform a variety of natural language processing tasks. And particularly, I'll be focused on GPT. This is probably the one that's really sparked this revolution, right? Generative Pre-training Transformer. This is a language prediction model that uses machine learning to produce human-like text. And you'll notice I emphasize a couple key terms here: prediction and human-like. And this is a clue that this is not AGI. While the results of using GPT can feel like there's a real sentience or thought going on there, it's not engaging in actual reasoning to produce results. So how does it work? Well, it's really all about the transformers, not the one developed by Hasbro, but the one developed by Google. This was the key breakthrough. Vastly simplified, there were pre-existing neural networks before GPT for doing this sort of thing, but the transformer technology enabled more parallelization. I am amazed I pronounced that word right. Parallelization during training and encoding. If you want to know more about that, we can talk about it later. It's machine learning stuff, right? And like I said, I'm not an expert. So greatly simplified, we start here with the prompt, natural language prompt. That prompt gets tokenized, where it gets, oh, my laser works. Okay, so it gets tokenized into a series of tokens or numbers, right? Roughly speaking, it's like a number per word, but it's not exactly the case. Some larger words will get broken up into multiple tokens. That results in what programmers would call an array, but what scientists call a vector, right? A series of numbers. And that's a dumb encoding, right? Where the real stuff happens is the encoding process after that, where each of those tokens gets an embedding for the token. And that embedding is another vector, which is, in the case of GPT, 1,294 characters or numbers. In GPT-3, it's 12,288 numbers. And at the time, I couldn't find out what GPT-4 is, but I heard they announced at the keynote it was something like 40,000. So you end up with this giant ass array, right? Or matrix, sorry. So the number of columns in the matrix is the number of tokens in your prompt, and then the number of rows is depends on which model of GPT you're using. So let's focus on, and then the decoding process takes that giant matrix and then starts to produce the output. And what I'm going to focus here is on this decoding process. So imagine that we start with a natural language prompt once upon a time, not long ago. So this is maybe what you type into ChatGPT. GPT goes through that encoding process, produces a giant ass matrix. That gets sent to the language model, and it does this beep, boop, beep, boop, beep, bunch of computation, and out comes a probability distribution. So you can see here, imagine this is a probability distribution over every possible token in the system. So, starting with A, ending with Zux, and then in the middle there, we see a couple that are the most likely ones. And then GPT will roll the dice and say, using this probability distribution, and let's say in this case, it picks when. And that outputs a single token, when. Now that token gets added back into the prompt, goes through into the language model, produces a new probability distribution, and you notice this one's a little bit different, right? Because now the prompt is different. And then it produces another token. And then it goes again and again until, so I don't know if anyone knows what this lyric is to. This shows my age. And then until it hits the end of sequence token, or you run out of tokens. So different models have different token limits. And the key thing to note here is, you might ask, when was that probability distribution? How does it get that probability distribution? When was that created? Well, that's where all that training comes into play, right? Like when it fed the massive amounts of data, it's creating all these probability distributions for all these tokens. The other thing to note is you'll notice that it doesn't distinguish between the prompt and the output. It's all part of the prompt by the end of the sequence. And it's producing a single token at a time using a stochastic process, a probability distribution. You can actually control that. Like if you ever use the APIs, you'll see a field called temperature. You could tell GPT, always pick the most likely one, don't roll the dice. But what we found is that, or what they found is that when you add a little randomness to it, you get better results. So what are some use cases of it? Well, we see summarization, classification, translation, question answering, and many others. But these are all really just variants of text completion. Just like we saw earlier, it's just completing the prompt until it runs out of tokens or it gets the end of sequence. And some strengths of GPT is that it can generate human-like text. It can generate stories that are interesting. It can generate articles that feel real, that feel like a human wrote it. But one of the weaknesses is it stumbles over facts and is inconsistent. So I'm going to show a quick example. So let's see. Yes. All right. In fact, if you look down here, I don't know if you can see that. It says ChatGPT can make mistakes. Consider checking important information. So I'm going to just do a simple one. I use snippets now because it saves me time. So I'm asked it to write a Wikipedia article about me. And if we look here, Phil Haack, prominent software engineer and open source advocate, where he played key roles. It may make mistakes, but I kind of like that one. But then it says I was born in Fulton, California in 1979. None of this is true. I did work at Microsoft, and I did work at GitHub. So you can see here, like, it writes this very human-like article, and a lot of this is really true, but a lot of this is really false, and it's not really easy to determine what's what, right? Let's do something even simpler. I'm just going to ask it to multiply two numbers, like, hey, computers are good at multiplication. Shouldn't it get this right? And it's, 3,036,000. This is what it produced, right? And we all know that's wrong. But for those who aren't as quick as me in math, I've already pre-calculated, and we can see that that number's wrong. So it can't even do basic multiplication. What use is this, right? Well, we'll look into some ideas to fix that later. So I'm going to switch back. Okay. But first, we're going to cover prompt engineering a little bit. This topic could be a talk in its own right. I'm sure others have done it. I'm just going to cover a few key points. So what is prompt engineering? This is the sort of the subtle art of giving an AI instructions to try to coax a result, a useful result. So in my previous slide, you saw like Aladdin speaking to a genie. It's a lot like talking to a genie, right? You have to be very intentional about what you ask for because you're going to get what you ask for. And sometimes that's not what you want. The prompt is the natural language text sent to or received from an AI. And you saw earlier when the AI produces a text, it gets added to the prompt. That's why we have that terminology for that. Now, when you're using GPT, prompts can have roles. You get more control when you're actually using the API versus the website. With the website, for example, there's a system prompt. This sets the overall context for the prompt, and it's typically used to configure an AI in some way. So, for example, you might configure the system prompt to be, you are a pirate of the 7 seas, right? When you're using GPT, the website, you don't see the system prompt. You can't see what they're doing under the hood, but you can bet it's probably fairly complex because they're trying to prevent you from jailbreaking it and doing all sorts of awful things. But people are very resilient at finding ways to exploit it. The user prompt supplies the question or command to the AI. Now, this might be someone typing in something to a bot, but in the context of your application, it might be you passing it text to summarize, or you passing it text to accomplish some goal in your app. So, for example, translate this text into Klingon, and the assistant role is the response to the prompt. Nukne gaj jamaj, which is translating that into Klingon, which GPT actually is pretty good at, surprisingly. So I've heard. So prompting best practices. First of all, start simple and iterate, right? It's an iterative process. I mean, this is the same thing you do when you're writing code. Be direct and specific. You can get good results when you get to the point and specify things like tone, length, style, format. Don't say please, for example. Like it may feel weird, like especially if you're from a very polite culture, but if you say please, this is a great example. Please often gives the starts to point to the training data where people are allowed to say no, right? But if you say write a story, it writes a story. If you say please write a story, it might say no, I don't want to. Yeah?
Can we thank it at the end?
What?
Can we say thank you at the end?
Oh, can you say thank you? Yeah, that's fine, but and probably not in your application. I think, so he asked, can you say thank you at the end? And I understand the impetus to like hedge your bets against sentience coming out and, like, hey, I was polite all those years, so, remember me when you take over humanity. But it's a stochastic model. We don't have to worry about this generation, but the next generation of AI, we may want to be more polite. I don't know. Put the instruction first. So start the user prompt with the main request, question, or the command. And then afterwards, provide context. Afterwards, you can provide all the necessary context that it may need to produce a good result. Providing examples is really important, and you can provide them in two ways: one in the system prompt, and one in the actually using the roles. So basically, you can. A very powerful technique is when you create the ChatGPT request, pre-populate a user and a assistant role response, and then it will use that in crafting the next one because it will understand, like, oh, this is what you're actually looking for. Because it doesn't know that that's not part of its history. And then experiment. Word choice, ordering, personas, all these can impact the results. Be positive. So Nike was on the right track when they say just do it. And this isn't just to be saccharine or nice. By being positive, if I said, for example, don't imagine pink elephants flying around this room, you're naturally going to start thinking about pink elephants. And language models kind of work in the same way. By introducing a concept, you kind of steer it towards producing output that has that concept. So for example, instead of saying don't do this, say do that, or keep it focused on this topic, right? And that is more effective than to reduce hallucinations and wrong answers. Speaking of hallucinations, give the model an out. So hallucination is a term that people come up with when it produces the wrong results, like when it said I was born in Cali. That's, we might call that a hallucination. But you can tell the model, look, say I don't know if you don't know. And that is one way to reduce those types of hallucinations. You can have it break complex tasks into subtasks. So if you wanted to write an essay, you might say, write 3 points for this topic, write 3 points against this topic, and then summarize that into an essay. Ask for its chain of thought. This one is really powerful, and I do this all the time in the app development, where I can store its chain of thought with everything it does so I can review it later, and you'll see that when I do the demo. But ask to explain its reasoning, what's the answer to this question, and tell me why you came up with that. And then check the model's comprehension. So I don't know if any of you know. Oh, you can't hear this. It's like, are you sure about that? Are you sure about that? Anyways. And then my best tip is use the playground. So I'm going to switch again. Let me see. Can you see that? Yeah. So this is playground.openai.com, or sorry, platform.openai.com/playground. And so unlike the website, the consumer website, here you can actually control all the different roles. And you can set the temperature, for example. So I'm going to start with a scenario I've already come up with, where for those who can't read it, I'm just going to submit this. Andreas passes the ball to Joao. Joao dummies the ball, and it goes to Lewandowski, who scores a goal, who gets the assist. And it says Andreas would receive the assist in this situation. And that's actually correct. The first time I did this ever, it got it wrong, but it's getting better. But imagine that I'm crafting I'm building an application that is trying to answer these, sports questions, right? This assistant answer might not be very useful. I may want this in a JSON format, right? So first, let's set a persona. We're going to set the system prompt. Oops. AI.referee. I can't spell. If I don't do it right, yeah, okay. There we go. And then I'm going to just do an example here. This usually works better than, there we go. So here you can see it's a little, let me zoom in there. So I'm setting up a persona. You are a world-class soccer referee. Please provide an answer in reasoning in JSON format. And then I provide an example in JSON format. So now I'm going to remove that response and submit this. And we get an answer, Andreas. It's succinct. And then I get the reasoning. And now that's useful. Now imagine that I mentioned using the roles for pre-populating examples. So now when I'm building an app, I might pre-populate every request with this. And then the next time an actual user asks a question, then I can populate that user, send the whole thing, and it's going to give me a really good response here. So, so if you were building a soccer application, this would be a way to do it. And I like that I'm actually in a country where we call it soccer, right? So everywhere I go, I get shit for saying that, and I'm like, okay, well, no one's going to complain here. Yeah. Well, most of you won't. All right. Okay, so let's, time for the main demo. So now I'm going to go into building an actual application. I'm particular to ASP.NET Core and all that, so naturally I used ASP.NET Core, EF Core, SignalR, Tailwind CSS plus Webpack, Mass Transit, Blazor, Refit, Azure.ai, OpenAI, and then I hosted it on GitHub. Do I win the buzzword bingo? Now, you don't need to know all these different technologies. The reason I'm using all this is I really wanted to build something that was interactive, real world, and that you could kind of clone and play around with and use as a starting point for your own applications. The first thing I'm going to look at is the completions API. And so, here's the endpoint. You probably will never do a post request directly to it. You'll probably use one of the many client libraries out there. But I'm going to show the app running. So let's try that. Okay. And, oh, shoot. Actually, I have to hit run there. And then I'll show the code in a second. There we go. Let me zoom in here. So this is a demonstration of a one-on-one chatbot implemented with the OpenAI ChatGPT API. So the idea is here I can ask questions like how many people are in Sydney? And it's going to respond with poop. So that's the application now, but like I said, now we're going to sprinkle some AI in there, right? We're going to figure out, the first thing we want to do is we want to use the completions API. So this app, as I mentioned, is using Blazor, it's using SignalR, and it's using Mass Transit. And the important part there is that Mass Transit is like a messaging system. So rather than making a call directly from the client or directly from that page, I want to decouple the AI part from the rest of the app so that I can reuse that part for any part of my application. So the long story short is eventually this ends up as a message to a consumer. And that class is easy to understand, well, relatively easy. So I have a bot message consumer. And the important part here is we get the message, and then we're going to send a response. And right now, it's just sending the codes for a poop emoji. So because you probably don't want to see me typing a bunch of stuff, I use a lot of snippets. But it's nice to see where I'm setting this stuff up. So the first thing we're going to do is we're going to create the chat completion options. And here you can see I'm setting up the system role message. You are a helpful assistant who is concise and to the point, and you are helping the user. And then I pass in like your username. And then we take the message that you sent and populate a user role. And now we just need to send that to GPT. Okay, so that produced a lot of code, but the important thing here is, whoops. Where's my, uh-oh. Oh, shoot, my computer's freezing. No, not now. And people complain about Windows. This is a Mac, and it's, oh yeah, David Fowler wanted me to show that I was actually using a Mac to develop ASP.NET Core. He's so happy about that, but, Jesus Christ. What do I do? Let's see. I don't have Control-Alt-Delete. Yeah. Here, let me I may have to power this down. This is a new one for me. Oh, man. So if you didn't, that's the Apple logo. All right. So I'll tell you what the code does, and then we'll look at it real quick, right? So we created that completions object, and then we send it to the completions API. We get a response. That response then gets sent as a SignalR message back into back to the app, and then gets rendered in the thing, and then it answers your question. Okay. So it's funny because I'm known for having demos break, and usually it's because I go off script or I start trying to do live coding. So I made a resolution, like no more demo fails. I'm going to use snippets. I'm going to do this. But you know, you can't tempt the demo gods. They will always find a way to. Yeah, yeah. All right, so. Oh my God! Now everything wants to start. C dev. Am I projecting? Oh yeah, I am. Okay. Script /all -e web -d. I'm using tmux, so okay. Oh, it looks like it's sort of, yeah. Man, that was a really bad crash. It's like, sorry about that. Okay, we're getting there. We're getting there. Let's see if we can run this, get back to where we were. Got a presentation mode. So interesting thing, you know, we get these a choice array, but it's always, you just always grab the first one. It's just the way the API is set up. When you're making a request, you can actually tell it, give me 3 responses, but it's always 3 responses to the same question. I haven't found any reason why I'd want that, but if you did. So then we're gonna send the response with the content of that, and then we have a try-catch around it, of course. So now if I go in here and I say something like, what is the height of Mount Everest? If all goes well, we see Mount Everest is approximately, and poop. So yes, I implemented it. I can get rid of this line now. Great. I haven't recompiled because, so it says Mount Everest is approximately 8,848 meters high. Great. So we've now sprinkled a little AI. So what if I want to ask another question, a follow-up question, right? Okay, how tall is that in feet? And says, I'm sorry, I can't provide information you're looking for. I don't know what you're talking about. So this is one of the first things that I got confused about when I was first building it, is that GPT, the API, is a stateless API. When you use the consumer website, you know, it remembers the state and it's keeping track of that, you know, behind the scenes. But in actuality, what it's doing is it's sending it your entire history back and forth over the wire to the GPT. And so we have to do the same thing. So what I'm going to do here is start to maintain a little bit of state. So let's see, we're going to add, I need some way to store the state. So I'm going to do something that I wouldn't really recommend in a real app. This is the part where, like I mentioned, it's a real world-ish app. So there are some things that I'm doing that I wouldn't recommend, but only because I haven't had time to implement the way I would do it yet. So let's go. So here I'm going to create a limited queue of chat messages, and we're going to store, let's say, the last 20 messages. In a real-world app, when you start to hit your limit of the number of messages you're sending, you know, you don't want to let that grow indefinitely because you're sending it all to the API and it costs per token. What I did in my last application is that once we hit a certain number, I started summarizing the previous history. So I'd summarize all of that into a single message. And then I removed all those messages and then kind of started a new queue from that point on. It's a bit of work to do, and I haven't implemented it in this sample app yet, but I will at some point, because I think that's, for a practical real-world app, you're going to want to do that. Although I'll show you something later that doesn't need that anymore. Okay, so I've set up where I'm going to store it, and then I need to, we need to populate the messages, right? Let's see. And then I need to take this message. Okay, so what I'm doing here is, so we're taking all the previous messages and we need to add it to that request. And then I need to take the message the user is adding and add that at the very end, which is right here. This is the new incoming. Does that all make sense? So I'm taking the entire history, every request, I take the entire history, then I add the new message to the very end. And the important thing here is that when I take the whole history, I need the whole history of the user question and the assistant response. And so then I will add that. And then over here, when we get the response, I need to add that to the queue. All right, so we want to keep track of both user responses and okay. I hit, so we'll stop here. I was worried that I was going to crash my computer again, switching from presentation mode to non-presentation mode. That wouldn't be good. All right, so I've redone that. And now I'll say, what is the height of Mount Everest? And how tall is that in feet? So now we've maintained state. And so that makes the app a little bit more useful. Okay, but this is going against public data, right? And public data that was probably trained like a year ago. What if you want to go against your own data? So let's go find my my deck. Oh wait, no, that's wrong one. All right. Okay, so that was an example of the completions API, and then I showed you how to maintain state. So now we want to use live data. And so now we're going to use something called GPT Functions. I think they're renaming it to tools. On the consumer side, these are plugins, but on the backend side, they're functions. And so you can describe functions that you're making available to GPT. And then the model will intelligently choose when a function should be called versus it should respond. And then it'll output a JSON object and send it to you and saying, hey, this user is asking for this information. Let's say they're asking for the weather. I've parsed it. Here's the JSON format, city and whatever. And then it's on you or your app to actually do the logic and then return a JSON response with the answer, and then it summarizes it. Okay? So this is what a payload for a function looks like, or this is what the definition for a function looks like. This is a simple arithmetic function where the description. So we give it a name. That's how we reference it. We give it a description, and the description is a prompt. That prompt determines whether. Oh, hands up. I'm sorry. Could you say that louder? Oh yeah, it's not a pre-trained thing. So a lot of times when people think, I want my own data in there, they think I have to train the GPT. Training is very expensive, and this is a way where you don't have to train the model with your own data, but you can still give it access to your data. So we're going to start with a really simple example, and then I'll get into a more complex example. So here I'm saying, hey, look, instead of you making up BS answers to math problems, I'm going to make available an arithmetic function. The description is a prompt, so that you've got to be really careful about how you write that prompt. But when that prompt determines whether or not this function is supposed to be called or not, and then you describe all the parameters. Well, we've got a left operation and a right. The left is a number, the left operand, the operation, and the right operation. And all of those descriptions are prompts. And then at the very end, we say what parameters are required, and in this case, all of them. So I'm going to go back to the code, and we're going to implement this function. Now, the first time I did this, I took that JSON format, I posted it in GPT, and I said, write this as a C# anonymous object, spit it all out, and I was able to just put it in there. It was really cool. But now, we're going to do it the hard way. Well, hardish way. So here's the completions API. We have this property called functions, and that's where we're going to put all our definitions. Rather than watch me do that, I'm going to, use. Unfortunately, I can't do that in there, so I've got to cut and paste this. But I'll show you what I did in a second. So this functions, it takes a list of function definitions. And right now, we're only going to have one, arithmetic. And as you can see here, it looks just like that JSON format, more or less. Now, writer here is trying to optimize my code. So I'll extract that to a static read-only field. Fine. And now that function is available. No. Oh, my goodness. What is going on? I blame writer. All right, sorry about that. Shoot. It keeps freezing up. I don't know why this is happening. Okay, so I'll just have to talk through that. So the next step is when we call the completions API, if I ask a question like how tall is Mount Everest, it's going to return a response of type with the role assistant. But if I say multiply two numbers, it's going to return a response with the role of function, and the response is going to be a JSON object or JSON text. And then I have to parse that, and then I have to take that, call, it will be in this case like, operand is multiplied, the left is this number, the right is that number. Okay, I'm going to not go into presentation mode on writer and see if that keeps it from crashing. I really apologize for this. I've practiced this multiple times, but never had it crash like this. Ooh, should have used VS Code. Yeah, maybe, right?
Escape.
What was that?
Command Option Escape.
Command Option Escape?
Yeah.
For what?
To force quit.
Oh, Command Option Escape. Okay. Well, it's weird because I couldn't even tab away to the different applications, but Command Option Escape. I'll try that next time. Let's hope there's not enough time. It's like, I'll try that next time. Yeah, this tells me it's a really bad crash because it didn't even close out my overmind socket. So, okay, we're running. All right. Let me just zoom in the old-fashioned way. Okay, so now we get this response. We've got to check that response for being a function call, right? So AI. Oh, actually, we've got to implement the function call first, right? So AI 08. Oh no, that was the right place. So response. Okay. So you notice here, if the response choice finish reason is a function call, we're going to call this call function async. So I'm going to do that as a local method, so it has access to all the context we need. So let's see, AI. Import all the missing restaurants. So it takes a chat message. It grabs the function call information. It deserializes that into my arithmetic arguments. And this is what you would expect it to be. Left, operation, right, and then I have this optional answer. And then I just call this method. I'm the one who's calling it, right? GPT doesn't call any code for you. Now, the important part is I get this result, right? I call the function, I get this result. I've got to pass that back into GPT. And so I serialize the arguments with the new result. And then I send that as a chat message with the role function. And then I call the completions API again. And then it will summarize it. So if I did everything right here, give it a moment. Now when I ask it to multiply, let's see, we'll just take my word for it. Okay, we're waiting. Let's see, did I miss? Oh, got a null reference. What happened here? Message content razor line 19. Uh-oh. Let's try this again. One more time. I feel like demo failures tend to have a compounding interest, right? So, okay, how tall is Mount Everest? Oh, the other thing that I did that's kind of neat is, okay. So you notice here on the right, it says the message addressed me and I'll try to respond. I got a response. It should show up in chat. So one of the cool things with Blazor is that you have this outlet where you can invoke, APIs in the browser. And so I use SignalR to send a thought anytime the AI is doing something. And then I use Blazor to send that to the console log so that I can kind of see what's going on, right? So now if I say AI.multiply, we see it says, oh, look, I know a function that can help. Arithmetic, left, this, right, that. And then blazor.web.js throws a message, a failure. So that message content line 19. Let's. Oh, you know what? I'm going to just get rid of this. This is starting next. Let's try that. That is really weird. This was working just earlier. That's what every speaker says. I swear this is working 5 minutes ago. Okay. One last try. This is worth it if I can get it to work. Let's see. Okay, so anyways, you notice here it selected the right function. We call that function. Oh, wait a minute. I think I know. So if I'm going to skip ahead. I have a backup plan. So luckily, I do everything in GitHub. So I'm going to just skip ahead to change branches, right? We'll save this branch so I can debug that later. Git co main. Now I'm going to run this. And I'm going to skip ahead to the issue with all that is that's a lot of work to define a function, right? So I wrote a little function framework because I'm a framework person. There's some of the other client libraries have function frameworks, but the idea is, we should be figuring this all out with reflection, right? And so I have a set of chat functions here. For example, the weather function, right? So the weather function, if you implement my chat function, you specify the arguments and the results, it will do all of that function definition generation for you. And then all you have to do is implement invoke async. And what's going to happen there is, I'm already over time. OK, I'll wrap this up real quick. So now I can call the weather API. So I can do something like, oh, I have 15 minutes? Oh, OK. Let's. Thank you, Aaron. Have plenty more time. OK, so what is the weather in Sydney? And what we'll see here is, OK, now it's working, right? So I got a function to call the result. I'll send it back to GPT to summarize. So when I said, what is the weather in Sydney? First, we get current weather. It determined, oh, you need to call the get current weather function. That's one of the functions available. Here's the arguments, location, Sydney. And then my app called the API with those arguments, and it got back this JSON object, temperature this, unit Fahrenheit. And then I summarize that, I take that and I pass it back into GPT, and then it gives me a nice natural language response. Now, where things get really cool is you can chain these functions together. And it took me a while to realize that. So for example, I have another function that can store information about me. So for example, I live in Bellevue, Washington. It's not a question. And it says, I know a function that can help store user facts. So it's storing this fact about me. And now if I say something like, I'm going to have to clear its cache because the fact that I live in Bellevue is now in the message history. So we're going to restart it so that's all cleared. The message history does not know where I live, right? So if I go here and I say, what is the weather where I live? So the first thing it's going to determine is, well, I need to know where you live, right? So it calls another function I have, retrieve user fact, and it says, where do I live? And you notice here I added my own parameter justification so that I can see why is it choosing that. So I'm trying to obtain the location to use it in getting the weather. And now it got that, and it said, oh, well, now that I had the location, I need to call another function, the weather function. And then finally, it says the current weather in Bellevue, Washington is 44 and 85 degrees, right? What was really interesting is, so in that code that I showed you earlier, where originally I had this as an if, if response choice finish reason equals function call. And I was trying to do this demo and it was failing. And I was like, what's going on here? And I realized, oh, when it calls a function, it could result in another function call. And I just assumed there's only a single function. So I went in and I changed this if to a while, and suddenly chaining starts to work. And that chaining is really powerful. I can do some really interesting things like this just off of a single function. So it can also chain the same function. So for example, let me look at what I have stored, because I better delete. I have all this. Okay. There's pre-existing stuff in here. So let's go back here. So for example, I'm going to say, and this is where the probabilistic nature sometimes, this is one I expect might work, might not work, but I worked with David Fowl. It's going to store that. It says David Fowl works with Chancelman. And then Chancelman works with Scott Gu. And Scott Gu's name is Scott Guthrie. Okay? So I've stored all this information about multiple different users. So I need to restart. I've thought about just cheating and just doing it right there because it already has that context, but let's do it right. And then I'll show you how it's working under the hood. Okay, so now I'm going to ask a question. So I said, please trace my work network until you run out of people or answer the question. Is Scott Guthrie in my work network? And now you're seeing it's actually tracing the relationships that I have, and it failed. This doesn't always work, but now I can prompt it though. You know about Scott. Let's see what. Or I should say, what do you know about? So this is the latest thing I've been working on, and it's a little tricky. I think I'm going to actually model these relationships in the database. So when I did, it didn't pick this up. So I'll show you the prompt that I'm using. It should have stored that as a, so I have this long description. It should store that fact about Hanselman with the Hanselman user. So, store information about a person when they make declarative statements, recognize this username format. And now this is the case where sometimes it works amazingly, sometimes it doesn't. The important thing here is, okay, well, I'm storing information. How am I storing this information? Well, GPT has an API for creating embeddings. So if you recall, embeddings are contain a lot of information, kind of semantic information about the text that or the prompt. So in this case, I'm calling a different API called the get embeddings, and I'm setting the fact as the prompt. And what that's going to do, let me switch back to my slides. Oh. Okay, so it's going to post to this API, the v1/embeddings, and it's the input and a model. And in this case, you want to pick a model that's appropriate for embeddings. So at the time, it's text-embedding-ada-02, but now there's a newer one, I think, that they recommend. And that's going to produce this big payload. But let's zoom into the relevant part, this embedding. Remember I mentioned those vectors, like 1,000 or 14,000 number vectors? This is an embedding. It's basically a vector pointing off into some higher dimensional space. The cool thing is if you have two embeddings, you can compare them using cosine similarity. Now, I know I don't need to explain this to you. Everybody here remembers all their high school trigonometry. But for my own benefit, I'll just remind you, if you have two vectors and they're at the same angle, that cosine is, or cosine of 0 degrees is 1, right? If you have two vectors that are orthogonal to each other, or 90 degrees angle, that vector, that cosine of that angle is 0. So the cosine of 90 degrees is 0, cosine of 0 is 1. And then anything in between is a number between 0 and 1. And it turns out if you have two prompts, let's say a fact and then the question about the fact, and you take the cosine, you get the embedding for each of those, you end up with two vectors pointing off into space, right? If they're really close together, they're highly related. If they're really far apart, they're not. And so you can then use a cosine similarity function to determine that. And originally I wrote it in C#, but then you have to pull every single record out of the database and compare them. That sucks. But it turns out that if you use Postgres and PG vector, you can, let me show the retrieve user fact function. So I can store vectors in Postgres, and then I use, with NPG SQL, EF core, and Postgres with PG vector, I can do this. And this query right there, that select, that is evaluated on the database server. Sorry, what? Oh, yeah. Sorry about that. Let's see. That right there, let's zoom in. So that select there, the embeddings cosine distance, that is being evaluated on the server. And what I'm doing here is I'm saying, grab all the facts where the and cosine distance is less than 0.25. Now that number, I wanted something pretty related, but I wanted to give it room to, find it, right? Like you can go 0.9, you can go 0.7. If you go too low, it'll return a lot of random info. If you go too high, it never returns anything. So that is more of feeling it out in your application. But this is the way that if you have information in your databases, you want people to be able to use natural language to query it, you're going to end up doing something like this. What I'm trying to do, again, is I want to create something useful. I find most LLM applications are not that useful yet. And so I'm trying to build something that's actually useful to me where I can store information about my family. And then when it's someone's birthday, I can just ask GPT, what should I get my son for his birthday? And so far, it's working pretty well. The whole network thing, who's in my work network, that was just seeing how far I could take it. And sometimes, you have to trust me, it works. All right. So the last thing I want to show, let's see, where am I at? Okay, so the Assistance API. Now, this is a new beta API, but it allows you to build a set of domain-specific assistants within an application, and they can leverage models, tools, and knowledge to respond to user queries. So basically, you can build your own Clippy. Let's see. Oh. This API is a little tricky to use. So if you see here, you have to upload files, you create an assistant, you create a thread, you post messages to the thread, and then you run the assistant against that thread, and then you have to poll the assistant for a response. So kind of complicated, but I'll show it to you in action so you can see why it's really interesting. So I have in my site, I have a whole thing for creating all these assistants. Oh, yeah. Thank you. So I'm not going to go through the whole process, but basically if I have a PDF file or some file with information, I can create an assistant with that file, and now I have a new domain-specific assistant. So what I wanted to do is I just moved into an apartment not too long ago, and I looked at the lease. It's this big, long, legalese, and I was like, I don't want to read this whole thing. So I uploaded the lease to my assistant here, and I created a lease assistant bot. And now I can ask it questions like, can I have pets in my apartment? And this API is in beta. It's a bit slow. You can see I have to poll. And so around the fourth poll, if I haven't gotten an answer yet, I tell the bot, just tell the user that you're thinking. So it's polling, and now I get this, according to the lease, pets are generally not allowed, yada, yada. But what's really cool here is I get this little footnote that references the specific place in the document where it got that information. So, unlike when you're using a consumer GPT and you're like, I've told it like, oh, write a response to this and cite your references. What does it do? It cites references, but it generates those references. So you go to the references, they don't exist. It just makes them up. But here, because I have a set of files that I've made available to the assistant, it can specifically reference where in that file it got that answer. So this is really useful, and I basically have now a factory for creating assistants. So I found a PDF with the rules of Uno. And I was like, okay, now I have an Uno assistant. And can you stack a draw 4 on a draw 4? And what do you think? Yeah, of course not. You can't. But everyone plays that way. And the assistant knows enough to say, oh, so I was playing around with it, and I changed the system prompt to be talk like a pirate. So the next Buccaneer must draw 4 cards to forfeit their turn. But it notes that, in some quarters, like basically house rules, most people allow you to do it, right? But yeah, so this API is really cool. And this shows one of the things about setting things up in a separate, what I call message consumer, is to use this API in my app, I just need to send a message, right? And it's the assistant. This consumer is doing all the hard work of like, okay, create a new message, create a run, and then start doing this polling. While I don't have a response, keep polling that run to get the response. So this, and then if the run status, if you get a response, but the status could be a function call. So now I have to handle that. So this one is a lot more tricky to use, but if you clone this repo, it's all right there, and you can tweak it and make it useful. Now, one of the cool things, remember before I said, oh, you have to manage the history of the messages yourself? Well, with this API, the history of the messages is actually persisted, right? You create a thread, you post messages to that thread. They're persisting that. And behind the scenes, they're doing the compaction that I talked about. If the thread gets too long, they'll compact that, they'll maintain that. Because you're still going to run into the token limits. I don't know what the pricing for this is yet. This is a beta, so I think they are still figuring it out. But really interesting way of generating assistance for your application. So that was the Assistance API. One key thing, if you're going to call this API, you need to add this header, OpenAI-beta assistance equals v1. Otherwise, it just doesn't work. Okay. So a lot of what I talked about, these are some resources. I'll try to send them out later. One of my favorite resources is the Wolfram article, like what is ChatGPT doing and why does it work? It's great if you really want to understand kind of under the hood how it works. The key thing to note is it's a predictive model. It's going to generate bad results, but if you really tightly constrain what it's working against, you can build pretty useful applications. In my last company that I started with my friend, we were building, we started off doing DevOps, but then we switched to customer success. And we were using GPT in a couple different ways. One is we would summarize conversations, and we were working in chat. If people stick to a thread, it's kind of nice because then you can say, oh, is this conversation done? Did their issues get resolved? But what happens is in the real world, people are messy and they're just throwing messages at all levels. And we were trying to use GPT to actually, extract those conversations out because we wanted to be able to answer the question, is anyone waiting on anything from us? Has their issue been resolved? What's their sentiment? And so in that case, we were building something that was really useful. And we had a few customers who were paying us a lot, but we didn't grow. We couldn't grow it. Like pandemic hit, all this stuff happened. And so we shut it down like last October. But I could definitely see like the inklings of, GPT and LLMs, can be useful in the right scenario. I just don't think we're seeing it yet, but I think, soon, like using these tools, using these APIs, building it in your own app, hopefully like you could build something that I'll find really useful. That top URL, that's where it is. It's github.com/hacked/AI demo. All my stuff is at Hacked. And I encourage you to check it out. Submit issues, submit PRs. Let me know what you think. I'd love to get your feedback. I apologize for the technical issues, but I think I was able to get the gist of what I'm trying to cover, and hopefully you find it useful. Thank you. Oh, any questions? I mean, we got a little bit of time, right? Yeah?
Play around with semantic kernel, which is like library over everything that you've done.
Oh, thanks. So having played around with semantic kernel a bit and the native functions in that, one of the issues I really ran into was around prompts with an arbitrary date, like you say today, even if I gave it functions for figuring out, okay, what's the current date, it would still try and put in like an actual today token where we're trying to accept date times. Have you run into anything like that with your playing around using the OpenAI API directly?
No, that's a really great question. I haven't tried anything with dates yet, so that would be really interesting to see how that responds. I mean, earlier you mentioned semantic kernel. I haven't played around with semantic kernel mainly because we were in Y Combinator, we had early access to GPT, so it kind of got fully into that ecosystem. And when I discovered functions, it kind of does a lot of what like semantic kernel does. What semantic kernel gives you the benefit of is using other models, other providers. But I was like, oh, I'm already here. I'm just going to use it. I do want to play around with it, but I haven't tried the date thing. So that's probably something I should add to it to see how it works. Because what I am starting to do is build out a lot of functions for all these different things that you can't get in GPT. So I was starting to build a function for understanding relationships between people, for example. So when I would say, like, so-and-so is my son, like that would understand that, create both users, do all that, rather than trying to have the single retrieve or store user info do everything. I was starting to break it down into smaller pieces, because I think like that's where GPT is really going to be useful, is once you have a collection of functions that can do the things it's really bad at. So for example, the arithmetic function. Now with that, anytime I ask a simple arithmetic question, it gets it right. The other thing is, like, I know Wolfram has a GPT plugin on the consumer side. I was going to try to implement it as a function because I wanted it in my app. But that would open a whole world of like possibilities, right? Where any scientific question is going to be accurate, right? Because I actually didn't check when I asked how tall is Mount Everest, I didn't check if that was correct, right? But if I hooked that up to Wolfram, I'd have a lot more confidence that's actually correct. Great question. Yep.
users or kind of or group of users?
Okay, so the question is, when you train the model, can you partition it for different groups of users? So I didn't do any kind of training, and I haven't played around with the training APIs, mainly because they're slow and they're very expensive. With the functions, I have total control, so I can totally do that. In fact, one of you didn't see it, but when I'm calling the store and retrieve user information, I'm passing the current logged in username as one of the arguments to my function. And that way I can do any kind of partitioning. I could do tenancy, for example. And so I really like the function way of giving access to your data over training. I think there are certain aspects where training makes more sense. I think, for example, if you're trying to train a body of like general domain-specific knowledge, like let's say you're building an aeronautics app, you're going to probably want to train it with really good information about aeronautics and all that stuff. But when I want to give it access to like user data, I actually don't want to train it with my user data. Instead, I use functions. Now, when I was using GPT, I also was worried about, okay, well, do I trust OpenAI to have access to user data? Do my users trust that? So we actually used, Microsoft has an API for doing redaction, right? So PII redaction. So we would do that, send it, and then get it back, and then unredact it for the end user. And then we're like, why don't we just go to Azure GPT? Because if we trust Microsoft to do the redaction and they're SOC 2, we should be able to trust Microsoft to just do the whole thing. And so we were starting to do that. But then Microsoft, at the time, they didn't have the assistance API. So it's a trade-off. Like OpenAI is always going to have everything first, and then Azure is going to follow. Like, for example, I didn't show it, but I have access to GPT-4 on the back end. And I didn't have that with Azure GPT, so that was a long way of not answering your question. Sorry. Question back there?
So when we pass in the user data, or I'm not sure with assistant and stuff, do we end up consuming tokens every time we pass that?
Could you speak?
Yeah. Do we end up consuming tokens every time we pass that to ChatGPT?
Oh, that's a great question. Yes. Yeah. So you are consuming tokens anytime you send information to it. So for example, you upload that file. That file is, it's a good question. So when you upload a file, you pay the token at that time. When you make the request, all the function definitions, that counts to your tokens. At that point, in the assistance API, the file is just a reference to a file. So that token count for that request is actually small for the file. I don't believe you pay the full file size. I think that's only paid once. But in the completions API, when I had the function definitions, if I have 20 function definitions, that's 20 definitions worth of tokens for every single request. So that is something that you have to consider, right? So I was starting to work on, in a separate branch, I was going to work on a meta function, right? So it's just a single function, and then it figures out what function to call, and then calls that function. So I'd only have one function definition, but it could handle everything. But I haven't gotten around to getting that to work yet. And it's really tricky because, if you look at the code, you'll see my store and retrieve user info functions. Those descriptions are really long because they're a prompt. So, yeah, I think they're still experimenting in this space. I think I could probably get that to work so that you're not spending so much every request. Go ahead.
Also, when you implemented that lease contract stuff, and then making query to the lease contract. When you implemented that lease contract to your lease.
Oh, the lease. Yeah, the lease thing.
Yeah. So when you implemented that, so it's just like one-off thing. It brings in token, and then you do cosine.
So with the lease, so you remember all that the cosine simulator? That was when I was using the chat completions API when I needed full control, and then they came out with the assistance API. I don't have to do any of that. It's basically everything I did earlier, it's doing behind the scenes. So you upload a PDF file, it scans it, tokenizes it, creates an embedding or a set of embeddings for that entire file. And then when I ask questions, it's doing cosine similarity. I'll be out here in a minute, so if anyone has more questions, come find me. Thank you.